Okay, so this is part two of the dependency project. I'm just going to just talk about a few ideas, just go through here. I'm not going to tell you the answers. Well, this is the last video I'm going to make for the semester, so I may be a little goofy today, so there you go. So, anyhow, it says, how old are you and what category do you fit into? Well, you got those three categories. You should know those by now. I actually fit into the retired class because I'm 67 and it says 65 and over would be in the retired class, even though I'm not retired. But that's part of, it's part of things. If you're in the working class, so maybe some of you were 19 or 20 and you're not working yet. So just because you're in the working class doesn't mean you're working. Just because you're in the retired class doesn't mean you're retired. But overall, it certainly does matter. How does the dependency ratio affect you currently? Well, it's hard to see, but when it's not just the ratio, but look at the 65 and older and how they're increasing in numbers by a larger percent. And then if you take the 45 to 64, there's a lot of people in this age group that are needing Social Security, needing health care. So it's kind of the priorities of the country have to be to take care. You just can't let the old people die. So you just have, how do you allocate resources? I mean, that's what it comes down to. The allocation of resources, because you have so many old age people and the ratio has been increasing. So you have more and more old age compared to working class. So when the ratio gets higher and higher, more and more income has to be diverted to the old age instead of like infrastructure or whatever. Okay, according to the article, why do baby boomers mean for the U.S.? Is that the first one? Well, according to the article, what baby boomer retirement means for the U.S. was the age dependency ratio in two. What was the age dependency ratio in 2 and 10? Does it match your calculations? What is it projected to be in 2030, according to the article? It probably doesn't match your calculations. They may have been using a different age group for the working class or a different age group for the retired class. So depending upon how they calculated it, it might not fit your calculations. I don't know. You have to read the article. The article implies old age dependency is worse, yet the ratio increased. Well, yeah, think about it. Think about, and I'm talking about the age dependency, that would be a combination of both of them. Think about what a higher ratio actually means, and think about it for people working and paying taxes, people not working and not paying taxes. So that's where you got to think about that. All right, I don't know. Somebody couldn't said that this didn't show up, but there it is. So you can hit pause and look at it. Recompute the three different ratios using the 2060 population, 2060, right here. So you're just recomputing the ratios. You've already done that, so that shouldn't be very difficult. And how old will you be in 2060? Hopefully you can figure that out. What are you going to be part of? I don't know. Some of you are so young, 2060, you're probably going to be middle-aged. Explain how the projected old age dependency ratio will affect you personally. Well, I would look at whatever you get here and compare it to 2000, to what you did in the last paper. And I can't tell you for the old age dependency ratio. Now you're looking specifically at this one, right? That one, which is defined here. Old age requires resources. So this keeps getting higher and higher. It's going to require more and more resources, including taxes, right? So I don't know how it affects you. You know how old you're going to be. All right, there's a drastic change in expected age dependency ratio in the year 2060 compared to what the values were in 2010. Explain this change and explain what it means for both the working class and the people, the rest of the population. Now, there's the different projections, right? From what I've been talking about, what you've been saying, if you're thinking about resources and taxes and things like that, that's kind of what they're implying there to look at. These are different age dependency ratio projections. Of course, hey, if the virus keeps killing it, old people may go down, like me. The virus gets us. Okay, so, well, you can read that. Determine the slope of the age dependency ratio equation, and that would be, I don't know which one, age dependency ratio equation. That is this line here, obviously. It gives you the slope, for crying out loud, and explain the meaning of the slope. Look, the age dependency ratio is increasing by 1.43% per year since 2015 to 2060. And you might say, is expected to increase by 1.43% per year. So there's a good hint on that one, which covers that one. The projected change, the percent change. Well, look, the projected change is the total change. That's just the number change. The percent change is the difference divided by the original, or change divided by the original times 100, right? You know that. From table 3, it's the projected total change. Yeah, you know that too. And these are giving you insights into what's happening. It's not the fact that there's going to be less people in this age group. It's the fact that this age group is increasing at a slower percentage rate than this age group. That's why the ratios get higher. 16. Let me take a break here. I'll come back. Okay, these problems are a little bit different, right? So assume that in 2015, the average American ate 5.46 pounds of food per day. How many grams of food is that per person per year? Well, I don't know what the relationship is. Google it. I don't know how many pounds equals how many grams. So first you convert it to grams, show the work, and then you multiply it by how many days there are in a year. Based on the above, how many grams of food did the average U.S. consume in 2005? Well, let's think about that one. Let me think about that one. Well, it seems to me if you made the first conversion, that's the answer. You can take the answer and divide it by 365, but why bother? Because the first conversion gives you the answer. Assuming the average food consumption decreases 1% from 2015 to 2016, how many grams of food would the average American consume in 2060? How many years is it? Hey, this is classic this. That's the classic formula you can use for that. When you're talking 1%, you're talking an exponential. Initial value, rate of factor, not rate of, the rate of change is decreased by 1%. What's the factor? All right, the world population, blah, 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 is 7.7 billion today. The world population growth rate is 1.05% per year. If it continues, what's the population? This is the same problem. This problem here and this problem here are the same problem. Doesn't look like there's any more. So I hope that at least gives you a little bit of a preview.